Good afternoon, everybody. Mr. Botra, are you here? Botra,
Yes, sir,
can you
yes.
hear me? Good, good. Guys, if you cannot, let me know. Thank you very much, Botra. Guys, let's continue. We're going to have two sessions today. Each one will be about 40 minutes, okay? And so far we talk about what is it, the differentiation rules, definition, and the last two classes were about the chain rule and implicit differentiation. And once again, you know, the only way to learn math is you need to practice questions. I'm not asking you to practice too many questions, but at least 2-3 questions, you know, just try to, how to say, convince yourself, okay, just that, okay, I have to learn this. Let me just find actually why it's important, okay? So try to solve one questions 100% by yourself, okay? If you don't understand, try it again. Only one question, try it again. And I hope at some point, you know, you start getting interested in this learning, okay? Otherwise, if you just say that, oh, I don't want to do that, or I cannot understand this, or, you know, this life is very short. Then after 5 years, you will be saying the same thing. After 10 years, after 20 years. So actually, it will be waste of time. And since now you're young and you have time, at least try, okay? Try. You understand or not is another problem. First, try your best. Let's see what happens. Now, guys, I'm going to talk about related rates today, okay? And next session, maybe the last 5-10 minutes, I may start linearization and differentials if you have time. Otherwise, related rates, for me, everything is important here, but I suggest all the students to practice as many questions as possible from this related rates. And also in your coming up, what is it, quiz 3, most questions will be from related rates. And also in the midterm exam, okay, and also most question will be from, most means that I'm going to ask a few questions. It really matters to get high score. For example, related rates in your quiz 3, at least there will be 4 questions from related rates, okay? Maybe from 1, 2, I can ask 2-3 questions, 3, 4, maybe 2-3 questions, 5 and 6, maybe 5-6 questions, and 3.9, I ask maybe 1 question, okay? But related rates, at least I'm going to ask 4 or 5 questions. So what is actually the benefit of studying this related rates? Well, number one, it really actually improves your understanding skill, comprehension skill. It enriches your vocabulary, okay? And also you will see that every question is, actually every problem is different problem related to different fields of, what is it, math or science, okay? And that's why I really suggest you to practice as many questions as possible from 3.8. So in this section, we look at problems that ask for the rates at which some variable changes when it is known how the rate of some other related variable or perhaps several variables change. So that means that actually so far we have been talking about the rate, right? Because when we talk about the limit problem, right, and in what is it, informal approach, right? And we were talking about the rate of change of the distance that gives us the velocity, right? Instantaneous velocity. And as you see here, most of the things in the calculus about rate problems. So the problem of finding a rate of change from other known rates of change is called a related rate problems, because rates are related to each other. Guys, just let's have a look at the procedure that we're going to through, okay, to solve related rates problems, okay? And of course, you don't have to memorize, but just try to understand. That means that just what we are doing here, we are just summarizing this. Number one, first thing. Okay, internet connection problem. All of a sudden, I don't know, my Wi-Fi is disconnected, so I had to change to 4G. Anyway, we are talking about the procedure to solve related rate problems. Okay, so now, of course, first you'll have to see a question, right? Have a look. And after that, read the question very quickly. You don't have to understand, right? Usually, that's the usual procedure, how we solve our problems. We call this scan the problem. And now, next thing is you have to read again a little bit slower. And if you are holding a highlighter, you have to highlight the keywords, right? And after that, if it is related to some visual things, so we need to draw a picture. Like for example, if you're talking about a box, draw a box. If you're talking about the distance between two cities, draw a kind of straight line that connects two cities. If you're talking about spanning bridge, right, just draw a bridge, right? And if you're talking about the building, I don't know, you should just sketch the building, right? Something like this. And use t for time. Assume that all variables are differentiable of time t, right? And now the second thing is write down the numerical information. That means that what is given. For example, let's say if you're talking about spherical container, the radius is given, or how much water in the spherical container is it, if it is given, write it down. And write down what you're asked to find. Now, see here in the previous session, we talk about implicit differentiation, right? And usually in implicit differentiation, we need to find dy dx, right? And that's why first we have to write down what are we going to find here, dy dx or dy dt or what, and write an equation that relates the variables. That means that after that, using that information, right, we need to set up an equation, and after that we have to differentiate with respect to t and evaluate and solve this problem. Okay. And let's start with this easy question. Now, example one. Now, see in the picture, we are given a kind of vertical wall, right? And this part is, what is it? It's the ground. A 20-meter ladder is leaning against a wall. So this is our ladder, right? It's leaning against a wall. And the base of the ladder, right? The base of the ladder is sliding away at 2 meters per second. Right? As see here, this, what is it? The foot of the ladder sliding away from the wall, right? At 2 meters per second. Since it is, what is it? Moving away. That means this dx dt, right, is given, is 2 meters per second. The question is, how fast is the top of the ladder sliding down the wall when the base of the ladder is 12 meters from the wall? Okay, because see here, two things are changing, right? Number one is when the foot of the ladder is sliding away from the foot of the wall. Let me just actually dash line here, right? Actually, it is moving in this direction, right? And also the top of the ladder, right? It is moving down, right? So these two things are changing. So like, for example, this horizontal distance, if I label this by x, if its vertical distance is y, right? X is increasing, right? Y is decreasing here. They are changing, right? So now the question is, first, we have to actually introduce the suitable variables to represent this unknowns, right? And after that, what are we going to find? Right? First, I have to ask myself, what am I going to find here? Okay, I have to make sure that, okay, I'm going to make this thing. And after that, we try to set up an equation, right? So to do this one, you'll see here, actually the ladder in this position, it forms a right angle triangle. It forms a right angle triangle. If the distance between the foot of the ladder to the foot of the wall is x, and let's say the original height, right, between the top of the ladder and the ground, right, it is y. At the time, I can write this equation using Pythagorean theorem, right? Here we have x squared plus y squared is equal to, what is it, 20 and squared. And but here, keep in mind that x and y, they are dependent variables. They are dependent on what? They are dependent on time, right? When the time changes, also x and y, they are changing. So that means that I can just write this thing. That means x is here a function of t. And also y is a function of t, right? So now I'm going to find dy dt here, because in the question is asking that how fast is the top of the ladder sliding down the wall when the base of the ladder is 12 meters from the wall. So that means that we need to find this dy and dt, right? We have to find this when x is 12 meters away from the wall. We have to find this, asking this, what is it? It's asking us to find this value of this dy dt at x equals 12, right? And now to do this one, by using implicit differentiation, I am going to differentiate both sides of this equation with respect to t, right? And now again, if you are differentiating x squared, right? So let's say this w, let me just write here. That means how can I differentiate this function x squared, right? And W is a function of X. X is a function of T, right? So what is dW dt? By the chain rule, I had to differentiate W with respect to X, right? And X with respect to T. So if we do so, what is the derivative of W with respect to X? That's equal to 2X. And how about the derivative of X with respect to T? I don't know. That is dx dt. Plus, in similar way for Y, it is 2Y times dy dt. And how about on the right-hand side? On the right-hand side, we have 0, because it's a constant number, right? So now in the question is saying that the base of the ladder is 2 meters per second, right? It is sliding away at 2 meters per second. It is increasing, right? This x, that's why it will be positive. Now you will see that when we solve this, you will see that this y will dy dt will be negative. So actually, when x equals this, right? When x equals 12, so we need to find, let me find for dy dt. What is dy dt? Dy dt is equal to, first I need to move this to the right-hand side and divided by 2x, right? So here we will have, what is it? 2x minus 2x, right? Over 2y times, and here we have dx dt. Or if you simplify this, that's equal to minus x over y times dx dt. So now in the question is asking that we need to find this dy dt, when x equals 20. So when x equals 20 minus x equals 20 over, when x equals 20, what is the value of what? And also we can find the value of y, right? Just open small window here. And we know that x and y, they are related to each other by this equation, x squared at any time, right? Plus y squared is equal to 20 squared. So is it 20? Yes. X is not 20, it's 12, right? Why did I write 20? It's 12. It is 12. Okay. So this one is also 12. So when x is 12 squared, 144, and this y should be equal to 256, right? So that is 16 squared is equal to 20 squared. So when x equals 12, y must be equal to 16. So that's 12, it must be 16. And how about dx dt when x equals 12 is equal to 2 meters per second, right? 2 meters per second. So that's equal to minus 24 over 16. And by 8, it is 3 by 8, 2 meters per second. And here we have negative, right? Why? Because it is decreasing, right? It is moving towards the origin. That's why it is negative. So actually, when the foot of the wall is, the ladder is 12 meters away from the foot of the wall, and if it is sliding away at the speed of 2 meters per second, then the top of the ladder will be moving down, right, at the speed of 3/2 meters per second. That means that every second, it is moving down by 1.5 meters. Next example, filling a conical tank. Okay, now we are given a conical tank. It says that water runs into a conical tank at the rate of 9 cubic feet, right, feet cubed per minute. Actually, this foot, we know that 1 foot is approximately equal to 33 or 34 centimeters, right? So anyway, it's American system, that's why it's given foot, and I don't want to change the picture here. So anyway, so the tank stands point down and has a height of 10 feet and a base radius of 5 feet. The question is, how fast is the water level rising when the water is 6 feet deep, right? So now actually we are given this conical tank, it is pointing down, right? And actually we are just pouring some kind of water. Maybe we have a tap here. The water is actually, what is it? Pouring into this container, right? Or flowing into this container. And here we have a tap. Okay, tap. So here it says that water runs into a conical tank, right, at the rate of 9 feet cubed per minute. That means that when you just open this and they keep a timer, right, and they set the timer, at every minute, right, the amount of water that flows into this container is 9 cubic feet, right? It's given here. The tank stands point down and has a height of 10 feet. Okay, it has a height of 10 feet. and a base radius of 5 feet. All right. How fast is the water level rising when the water is 6 feet deep, right? And suppose that water level, right? The water level is, let's say, this y. In the question, what is it asking here? In the question is asking how fast is the water level? Just highlight this, water level rising, right? When the water is 6 feet deep. So now if, again, label the height of the water by y, right? The question is, we have to find the thing then. We have to find, what is it? The water level, right? How fast is it changing with respect to time when its depth, right? Y is equal to 6. We have to find this, right? Now to do this one, as you see here, the water is flowing into the container, right? That means that the amount of water in the container is changing, right? That means that also the height is also changing. And also the radius of the top of the water, also it is changing, right? 3, 4 things, they are changing at the same time, right? So our job here is how actually these rates are related to each other, and how do you find this if 1 or 2 rates are given here. Now to do this one, first we have to find actually, what is it? The amount of water in this container, right? So let's say, for example, after certain minutes, right? So amount of water here will be what? So if the radius is x, right, the top of the radius is x, and it is y, we know that actually the volume of the water in the container after certain time, it will be what? It will be, it's just a cone, it will be 1/3 times pi r squared times h, right? So, but instead of r, we have used here x. So here we have x squared, right? X squared and times y. Y is the height, right? So now, actually, I need to find dy dt, but here we have no, I can find this, but we have no information about how dx dt is changing, right? So that means that how can I have an equation only in v and w? I mean, sorry, y, right? So that means that how can I eliminate this x from this equation? And to do this one, first, I need to find the relation between x, y, and v, how they are related to each other, right? And now, if you just consider or visualize the cross section of this cone, right? If you're just cutting with a knife that is perpendicular to the ground and through the center of this cone, right? And you will have this kind of triangle then. You will have this kind of triangle, right? The triangle, and this part is, it is x, right? And the top, it is 5. And this one is, it is y. And since the height of the cone is, it is 10, so this one is, what is it? 10 minus y, right? And now these two triangles, this small right angle triangle and the big one, they are similar to each other. Similar to each other means that their corresponding sides must be proportional. If I just label this angle by alpha, right? Opposite alpha, here we have x. In a big triangle, opposite alpha, we have 5. Or else you can just use tangent of alpha. Tangent of alpha is opposite side over adjacent side, right? And now, and how about if I label this angle by beta, right? In small triangle, right, this is also beta because they're parallel. Opposite beta, we have y. And in a big triangle, opposite beta, we have 10, right? Now from here, say I can find the relation between y and x. So what is y? Y, x, I need to find x, right? Because I want to eliminate x from the equation. So x is equal to, multiply both sides by 5. So 5/10. So here we have 1/2 times y. So x and y are related to each other by this equation. So now if I just substitute this into our volume equation here, what do I get here? Here we have volume is equal to 1/3 times pi, actually just a constant. Maybe to save some space, I can just write it as pi/3 times x. What is x? X equals 1/2 y. And here we have squared times y. And now if you simplify this, 1/2 squared, that's equal 1/4, right? So here we have pi/12 times, and here we have y squared times y. So here we have y cubed, right? And now we have just actually, we call this reduction, right? We have just reduced the number of variables in our equation from 3 to 2. And now I can differentiate both sides with respect to t, right? And considering that, or assuming that v is a function of t, because when time changes, also the volume of water is changing in the container, and also y is a function of t, right? Now, if you differentiate both sides with respect to t, on the left-hand side, I have dv dt. I have dv dt. And how about on the right-hand side? By, again, using the chain rule, right? And our function is a function of y is a function of t. So pi over 12 is just a constant number. Differentiate y cubed. So that's equal to, first with respect to y, that is 3y squared. Now I have to differentiate y with respect to t. So here we have dy dt, right? dy dt. And that's it. Or if I just simplify this further, 3, they cancel each other. So here we have pi over 4 times y squared times dy dt, right? So what we have to find here is I need to find dy dt, right? First, let me express this in terms of the other variables in the equation. So here we have then dy dt is equal to, move these two guys to the left hand side, right? So here we have 4 over pi times y squared, and on the right hand side we have dv dt, right? Now we can evaluate this. What we have to find here is I need to find the rate of change of y with respect to t when y is equal to 6. That's equal to, so here we have 4 over pi times, what is our y? It is 6. It is 6 squared times, and how about dv dt? dv dt is given here, right? dv dt is changing at this rate, constant, right? It is 9. So here we have 9. That's equal to 4 times 9, 36. 36 over 36, that's 36. That's equal to 1 over pi. Since it is height, right, it's changing by feet, right? Feet per minute. Okay. So when actually the level, right, the height of the water is 6 feet, at the time, actually it's level, right? The height is changing at the rate of 1 over pi feet. And now if you change the number, again, it will be, what is it? For example, how about when y is equal to, for example, let's say it is 7, it will be smaller than this, right? Because as we move up, right, the top part of the container is getting bigger and bigger, which means that the water level is changing much slower than the previous times. Mr. Botra, is everything okay?
Yes, sir.
Where are you now? In the library?
I'm with friends right now.
All right. Okay. Let's continue. Next question. Pumping out a tank. We have some water in the tank. How do we empty the tank? Right? How do we pump out the water outside? How rapidly? How rapidly means how fast, right? How rapidly will the fluid level, right, inside a vertical cylindrical tank drop means decrease, right, if we pump the fluids out at the rate of 3000 liters per minute? Okay. So now, again, it says that how rapidly will the fluid level inside the vertical cylindrical tank drop if we pump the fluid out at the rate of this, right? So that means, as you see here, we are pumping out, right? That means that the amount of fluids inside the container is decreasing. And that's why it must be, what is it? It must be negative number, right? Decreasing. Increasing, it is positive. If you remember, if you're talking about the position function, if this one is the reference point 0, right? Reference point 0, the same. If you're moving in this direction, moving away from the position, that means that your velocity is positive, right? If you're moving towards the origin, right, that means that you are getting closer and closer, that means that your velocity is negative. And now here the amount of water is decreasing. That's why it must be negative. Look here in the question, in the quiz or midterm, guys, let's say the answer is -10. If you write 10, it will be wrong answer, because you need to differentiate between when it is negative, when it is positive. Okay. So this is dv dt is given, right? We have to find the rate of change of it is level, right, at time t. So now to do this one, suppose that it is actually, what is it, volume is V. How do you find the volume of a cylinder? If the height is h, right, is equal to pi times r squared times h, right? And see here, the radius is constant here because the cylinder, right, as the liquid changes, its radius is not changing. So here, our radius, it is constant. It's not changing. It's not like cone, right, or conical container. So now if you differentiate both sides with respect to t, here we have dv and dt is equal to this pi r squared. It's a constant number, right? It is pi r squared. And here we have dh dt, right? And now this thing is given by 3000. So first I need to find this dh dt. dh dt is equal to 1 over pi r squared times, here we have dv over dt, right? So now if you evaluate this, one is changing at this rate, this will be 1 over pi r squared. And what is dv dt? dv dt is equal to minus 3000, right? That's equal to minus 3000, 3000, okay? Or that's just equal to minus 3000 over pi r squared, and it is liter per minute, right? The height is given what? And if it is liter, height is given, let's say, the centimeters per minute. Okay, it is changing at this level. Okay, maybe I can change actually here. If you're talking about centimeter, I need to change first liter into centimeter, right? This 3000 means that, what is it? That is because liter, let me just write here, we know the 1 liter is equal to, what is it, 1000 cm cube, right? Cm cube. So because this r centimeter, right, r, if it is given in centimeters, let's say, okay, so at the time it will be okay, it will be really small, but what can I do? Anyway, let me continue here, equals, so at the time we will have minus 30,000, 3,000 times in centimeter. I think I would express it in what is it? Meters, 10 cm cube, right? So 10 cm cube is, what is it? It's 1 over 10. So 1 meter over 10, right? It is cube. So that's equal to 1 meter cube over 10 to the power of 3, right? That's equal to this. So anyway, guys, let's continue. So here we have then minus 3000 over pi r squared times, and here we have, what is it, times 10 cube. So that's equal to minus 3 over pi r squared meter per minute. It must be this, this will be this much. Because units is not mentioned here. If you want, you can just leave it your answer as centimeter per second or meter per minute, depending on which one is more suitable. But here, see here, we don't know the radius. It depends on the radius. If the radius is bigger, right, that means that the rate of change will be smaller, right? It drops slowly and slowly. If it is big at the time, I mean, if the radius is small at the time, it actually drops, right, so fast. So one more question, then after that we'll have a break. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the lift-off point. At the moment, the rangefinder's elevation angle is, that means angle of elevation, is pi over 4 radian. The angle is increasing at the rate of 0.14 radian per minute. How fast is the balloon rising at that moment? Now picture is given because these are solved examples. As we said in the first slide, right? If nothing is given, after reading the question, you need to sketch the graph. So if you're talking about the balloon, imagine that you are standing on the ground, right? If I have no picture here, how would you describe this? You know, actually this guy here, we have Botra is standing here on the ground, and this one is ground, right? And he was bored, maybe he's flying kind of kite, right? And he's just watching this. And here we have kind of balloon, right? Balloon is flying, right? So we are talking about this thing, okay? And we are talking about this angle, and the height is changing, and blah, blah. But here it's given, that's why I don't have to redraw this. Okay. Now let's try to understand the question first. We had just actually scanned this question. Now we have to read one more time, a little bit slower. So we just write here solution. A hot air balloon, so we're talking about this balloon, rising straight up, right? Straight up, okay. From a level field is struck by a rangefinder. So this one is the rangefinder, which is 500 feet away from the lift off point, right? At the moment, the rangefinder's elevation angle is pi over 4, right? When theta is equal to pi over 4, the angle is increasing at the rate of 0.14 radian per minute. How fast is the balloon rising at that moment? Okay, so how fast is it rising at that moment? First, we have to, what is it now? Okay, we're going to find this. What are we going to find here? We are going to find how fast is the balloon rising at that moment. So we have to find this dy dt, right? That is a height. How fast is it rising with respect to, how fast is it changing with respect to time? When what? Increase the rate of this. So, okay, when theta is equal to pi over 4. Actually, it's asking this thing, right? How fast is the height of the hot air balloon is changing with respect to time when theta is pi over 4. Okay. Now to do this one, what should we do here? I think we need to use the tangent function, right? Let me just use here. So here, what is tangent function? Tangent of theta is equal to opposite side over adjacent side. That's equal to y over 500, right? Or I can just write here as, what is it using this one? I can just write here, what is y? Y is equal to 500 times tangent of theta, right? So now I need to find dy dt. So immediately let's differentiate both sides with respect to t. So here we have then dy dt on the left hand side, and now 500 is a constant number. And tangent of theta, even in the class, I asked what is the derivative of tangent of theta? It is secant square root of theta, right? So now our function is a function of tangent. Tangent is a function of theta, and theta is a function of t. So now if you differentiate tangent of theta with respect to t, at the time here we have secant square root of theta, right? Times. Now we have the differentiate theta with respect to time, t. So here we have d theta, dt, right? And now I have to find, what is it? This thing, dy dt, when theta is equal to pi over 4, right? So that's equal to, here we have 500 times, and here we have secant square root of, what is it? Pi over 4 times d theta dt. How do I know this one? Is it given? It is given, right? It's saying that the angle is increasing. This theta is angle, right? At the rate of 0.14 radian per minute at that moment. So here we have is given, that's equal to times, let me just write times like this. So here we have 0.14, right? And that's it. And we know that from here, 500, where it is 0, 5 times 14. 5 times 14 is, that's equal to 70 times. And what is secant function? Secant is 1 over cosine, right? And cosine is equal to, what is it? Cosine of pi over 4 is equal to 1 over square root of 2. That means that secant of pi over 4 is equal to square root of 2, right? And now if you square this, here we have 2. And that's equal to 140. And since it is a height, so it is changing at this rate, feet per minute. So at this moment, right, the height of the balloon is changing at this rate. Guys, let me stop here. Okay, because next question takes about maybe 8-10 minutes. let's have break. Okay, at 3 o'clock I will continue. All right, enjoy your break. See you after 15 minutes.